Back to your favorite intermediate algebra course. We're going to talk about exponential growth today. We're going to graph some, we're going to use some growth models, look at some compound interest, which is an application of exponential growth as well. But let's take a look here at the definition first of all, an exponential growth function. So it's a function of this form, f of x equals a times b to the x, where your a is positive, and that's a requirement here for exponential growth, and your b's got to be bigger than 1. So for example, let's take y equals 2 to the x, okay? F of x equals 2 to the x. So in this case, if you think about this, a times b to the x, so my b is 2, and my a in front is just 1. It's just like 1 times 2 to the x, right? So your 1 is positive, a is positive, and b is bigger than 1. So it meets the exponential growth requirement, and you'll see how this thing grows exponentially once you start plugging in some points. So why don't we plug some in here and take a look at this. Let's plug in 0. What does that give you? 2 to the 0, right? So y equals anything to the 0 power, 1, right? Let's plug in 1. F of 1, 2 to the 1, 2. So when I plug in 1 for x, it spits out 2. Let's plug in 2 for x now. Y equals 2 to the x. My x is 2. 2 squared, 4. Y equals 4. Let's plug in 3 now. 2 to the x. X this time is 3. So plug in 3 in for x. 2 times 2 times 2, 8. Okay? In fact, let's put those on the graph right now, and then we'll keep going here with some points. 0, 1, 1, 2, 2, 4, 3, 8. Okay? So far you can see how this is kind of curving up real quick right there. Let's go to the left though. How about negative 1? Let's plug in negative 1. What's 2 to the negative 1? Okay, y equals 2 to the negative 1. Of course, that's 1 over 2 to the 1, isn't it? Or 1 half. So we got 1 half. Negative 1, I'm only up a halfway. How about negative 2? Y equals 2 to the negative 2. 1 over 2 squared, or 1/4. Plugged in negative 2, we got a fourth. So I'm only up a fourth of the way. How about negative 3? That's 2 to the negative 3, or 1/8. Let me extend this a little bit. Okay, well if I plug in negative 4, 2 to the negative 4, 1 over 2 to the 4th, 1 over 16. Negative 5, I'll be 1 over 32. What's happening as I shoot out? As this thing shoots to negative infinity, do you notice what your y value is doing there? Notice how you're getting closer and closer and closer to 0. Okay, that's the definition of a horizontal asymptote. So this thing has a horizontal asymptote, has what's called a horizontal asymptote. That's horizontal asymptote. If you remember asymptotes, we've dealt with vertical ones before. Horizontal asymptote y equals 0, okay? So in other words, a horizontal asymptote, as you shoot out to an extremity, okay, either negative infinity or positive infinity, it's going to approach that y value, okay? So let's see if I can draw this here. Okay, and this thing is slowly, slowly, slowly getting closer and closer to 0, okay? So this is y equals 2 to the x, okay? Y equals 2 to the x. Now you're going to have some manipulations. This is like your parent graph for an exponential function. So what would, let's consider now a different one here. How about, or you know what, I don't want to do that. I'm going to leave that up there. Okay, so here's y equals 2 to the x. All right, what would, let's say you move this around a little bit. What if we went 2 to the x, but then we went, let's go like that, -3. What's that going to do? So you still do your plug the points in if you're not sure. 2 to the 0 is 1. 1 minus 3, negative 2. So 0, negative 2. So it took this point right there and it moved it down 1, 2, 3, didn't it? Moved it down 3. So that's right there, and you could do a whole bunch of other points, but if your original function was 2 to the x, then a 2 to the x, and outside of that minus 3 on the end, that's just going to be a vertical shift, as you might assume, a vertical shift down 3. Let's check another point. How about 1? 2 to the 1 minus 3. That's negative 1. So 1, negative 1, 1, negative 1. Okay, you see how this point was moved down 1, 2, 3? Okay. That original horizontal asymptote of y equals 0, that's also shifted down 3. Okay, so this thing ends up being, you could plot some more points and so on, but there is your 2 to the x minus 3. Okay, so shift down 3. Let's do a shift, different kind of shift, another rigid shift here. Let's go, how about 2 to the, let's go x minus 4. Let's do that. What would that, now that x minus 4, that's all in the exponent there, so that's kind of a small 2 to the x minus 4, if you will. Okay. Well, let's plug some more points in. What would I have to plug in to make the exponent, the entire x minus 4 right there, to make that 0? And you'd say, well, I got to plug in 4, don't I, to make that 0? So why don't we start there? 2 to the 4 minus 4, y equals 2 to the 0, which is 1. So when I plug 4 in, I get 1. 3, 4, 1, 4, comma 1. Let's go to the right a couple. How about 5? How about 6? So 2 to the 5 minus 4. That's 2 to the 1. So 5 comma 2. 5 comma 2. 6. Y equals 2 to the 6 minus 4. So y equals 2 squared. 4. 6 comma 4. 6 comma 4. Right? We can do 3. Let's go to the left now. Let's plug 3 in. 2 to the 3 minus 4. 2 to the negative 1. 1 over 2 to the 1. So 1 half. 3 comma 1 half, and so on. So anyways, you could do a bunch of these as well. And you see that. So in comparison to the blue function there, did you notice this is a really big point right there, 0 comma 1. That shifted over how many? 1, 2, 3, 4, and it ended up right there, didn't it? So that, when you have that as a part of it, so it's a composition, f of x minus 4 is the composition there, that minus 4 up there in your exponent, that's going to shift that thing to the right 4. So horizontal, shift, right 4. Well, you can imagine if it was 2 to the x plus 4, that'd shift it left 4, right? Now your asymptote is still y equals 0 because I just shifted it. To the right, didn't I? Okay. So that's up, down, right, left. Let's think about reflecting this thing about the x-axis. So how about this one? F of x is negative 2 to the x, okay? Or sometimes you'll see it, so it's a little more explicit there. Okay, so that's telling us, hey, you got to do the 2 to the x before you apply the negative out front, right? So for example, you plug 0 in, negative 2 to the 0, right? Negative 1. Plug 1 in. Negative 2 to the 1. Remember, you do the 2 to the 1 first before you apply that negative out front, so you get negative 2, right? Plug 2 in. Negative 2 squared. So negative 4. Okay? So 0, negative 1, 1, negative 2, 2, negative 4. Anyways, you can do all these, and you notice that, hey, you see that reflection? That's your reflection. That negative out front is a reflection about the x-axis. Okay? So reflection about x-axis. Okay? Now all of these had either a 1 or a negative 1 out in front of the 2, right? So if you had something, let's go back to the definition here. So if this a was something besides 1, okay? So like you had 2 or whatever, it's gonna make that growth go a little faster, right? After. Well, let's do one here. Extend this a bit. So for instance, let's do y equals, I don't know, 3 times 2 to the x, right? Plug in 0. 3 times 2 to the 0. 2 to the 0 is 1. 3 times 1. So 0, 3. So on the graph, instead of 0, 1, that really critical point 0, 1, right? Now you got 0, 3. 0, 3. Right there. Okay? Plug in 1. 1. Well, 2 to the 1 is 2. 3 times 2 is 6. So 1 comma 6. Let's go back up here. 1 comma 6. But anyways, you could do a bunch here, and it shoots up real fast there. Whoops. I should put in negative 1, but negative 1 would be 3 halves. 1 1/2. Kind of missed that there. Oops. There we go. Anyway, so that's what that 3 out front does, okay? So changes the growth of that, if you will, okay? So that's shifting graphs of the form a times b dx, where a is positive and your b is greater than 1. Okay? Now let's talk a little bit about the domain and range here of this thing. So originally we had this 2 to the x, right, which goes through that critical point there, 0, 1. So this is y equals 2 to the x. We had this horizontal asymptote at y equals 0. Okay, so your domain of this thing would be x such that, and you're looking at this thing, you're like, oh yeah, I got all my x's are covered here. I can plug anything in for x, right? So you got this all real numbers if you're looking left or right here. And your range, you say, well, what's the lowest y value I got? Looks like about 0. I don't quite touch it though, do I? So I say, and I go above it. You see how it's anything above the 0 here? Okay, so my range is going to be y greater than 0. Okay. Now when we shifted that, I think one of those shifts, didn't we bump it? I can't remember which way we bumped that. Down 3. Okay. So we did that one where we took that, went down 3. So this was like that type of deal. And then we had the new horizontal asymptote, y equals negative 3. And this was 2 to the x minus 3. So let's talk about the domain on this one. 2 to the x minus 3. This is out, so that's a big 3. 2 to the x and then minus 3. Okay, your domain here, again, it's going to be all real numbers, right? I can plug anything I want in. I got no restrictions on that x there. Okay, left or right, I see there. It encompasses all those x values. Now your range has all of a sudden changed, right? So notice we bumped it down 3. So my y's are now going to be greater than that negative 3, right? They don't ever quite touch that horizontal asymptote of negative 3, but it's everything above that, right? The y's shoot up.